Hello student, let's try to understand a problem student. This is asked by my student only. This problem is somewhat good problem you can say. How can we solve this problem? Let us see the question. Give the major product that are formed by heating each of the following ethers with HI, right? So when you are dealing this question student, okay, you should know the mechanism, then it become very easy. Otherwise in the 12th standard what is there, mechanism is not there, direct reactions are there, and it makes very difficult student. Then in this case you need to memorize, and how many reaction you can memorize. That is why let us look over it student. What can you do? This is CH3, here is this is CH2, this is CH, here is what is there student, CH3, this is CH2, here is O, this is what is CH2, and here is CH3. Now student, what you are going to do, here HI is there student, HI. So what is there? It will give H plus I minus. So here is the H plus there student. You know oxygen is having lone pair electron. So what will happen? This lone pair electron accepting this one. So it will give the protonated ether student. This is the CH3, CH2, here is CH, this side it is the CH3. Here is CH2, this is the O, downside it is going to be H student, and here is CH2 and this is CH3 obviously, and it will acquire the positive charge. Now here is the attack of I minus you see student. Now here it is the tricky that whether you are going to attack the I minus smaller or the larger bulky group. Okay, so now what you have to see student, if suppose the after splitting what will happen student, after splitting this will become the carbocation, either this will or this will become the carbocation, so that the negative charge attack, right? So if this become carbocation, if this is carbocation, so how many alpha hydrogen? One alpha hydrogen is there, one alpha hydrogen, and it is having 3 alpha hydrogen. So which is going to more stable? This side. Second region is also there student. What the second region? Which one attack is easy student? In this case bulky group is there, so backside attack not possible, so it will attack on this position student. So this bond is splitting like that. So what the major product you are going to get? CH3, CH2, here is CH, this is CH3, this is CH2 and OH. And secondly other one is what is there student? CH3, this is CH2I. So you got to know student, more the alpha hydrogen, more is the stability of the carbocation. So more here is 3 alpha hydrogen is there, so it attack. Now let us see the second one. Second one is the little much better than the first one student. Here you see the second one. It is excellent question student, you can say. CH3, this is CH2, CH2, here is O, this is C, here is the CH3, this is the CH3, here is the CH2, and this is CH3. Now you are the similarly it is the attack will be what is this is H plus I minus. So obviously the attack of what will be that H plus ion, because the ethers are the electron rich species. So how the attack will be there here? It is going to form the protonated ether student. CH3, CH2, CH2, O, downside it is going to be H. Here what will be there student? C, this is the CH3, here is a CH3, this is CH2, and this is CH3. Now we have to see either it will acquire the carbocation student, or it will after splitting it will acquire the carbocation. Two conditions are there. If you are considering this carbocation this side, so number of alpha hydrogen 2 alpha hydrogen are there, and if you are considering this carbocation, so alpha hydrogen 9 alpha hydrogen are there. So 9 alpha hydrogen, this is going to be more stable, this is more stable student, more stable, and this is going to be less stable. So I minus is going to attack where student? I minus, this is going to attack where student? This is going to attack on this position. This bond is splitting like shifting like that. So what you are going to get here? This is the most interesting question given in the NCERT student. So this is the alcohol, and that is then you will find CH3, this is the CH2, here is C, this is CH3, here is CH3, and this is the I. Now the lastly we are going for the third one, student. Let us move out to study the third one. Third one is also tricky one, the better one. See student, the benzyl carbocation is more stable than phenoxide ion, and here moreover it is the partial double bond character is there, so I cannot attack here. Okay, I cannot attack here. So first of all, what will happen, student? This is the H plus is attacking here, this is the lone pair electron, so obviously this is going to form, student, the intermediate. Let us write down here, it's taking time. This is there, student, this one is there here, this is the CH2, here is O, downside this is H, positive charge here, student, dear student, this is there. Now if you consider this one, okay, so where the possibility is there, student, this position, this is the more stable, student. Benzyl carbocation is stable, student, more stable compared to phenyl carbocation, less stable. So where the I minus can attack, student, where it can attack, obviously it will attack on the more stable carbocation. So the product when you are writing, dear student, this is CH2, I is here, student, plus the obviously other will be going to be the phenol. So this is what our required answer, student. Thank you very much for watching, dear student. So in all the cases you should know, student, here you see the stability, student, stability, that is either the carbocation will be this one or this will be. So here alpha hydrogen, 3 alpha hydrogen more stable, here alpha hydrogen, 1 alpha hydrogen less stable. So I is going to attack with this, student. So that is, you see the product CH3 CH2I. Other case you see, student, here this is the alpha hydrogen, you are considering how many alpha hydrogen are there, 9 alpha hydrogen. Here alpha hydrogen, how many are there, 2 alpha hydrogen. Obviously this is more stable, so I is going to attack here, student. So this is the product. So thank you very much for watching, student.